Hello dear friends, welcome to the lecture of numerical methods. We will start the paper of numerical method, and today we will study the first chapter as interpolation. Numerical methods are important in mathematics, also in engineering and physics. If you want to solve an equation, whether the equation is algebraic or a differential equation, and if there is no exact or analytical method available to solve such equation, then we can apply numerical methods. Numerical method give at least approximate solution to the equation, and therefore these are important. And in the interpolation, in this lecture we will study finite differences. Also we shall study forward differences, backward differences and central differences. Now what is meaning of interpolation? If we have given a table of values, so these are see xi, yi, I takes value 1 to n, or that means if we have x values and y values, the values of x are x0, x1, x2, etc. and so on. And if the values, corresponding values of y are denoted by y0, y1, y2, etc. So these values will satisfy a certain relation, or it is a function. The relation between these two values y and x is a function, y is equal to f of x. But if we don't know what is the function, exact function, then we have to estimate such a function here. Or if these values are given and if you want to find a value of y which is not in the table, and that means we have to estimate certain value of y for given value of x, and that estimation can be done by obtaining a polynomial. We will find a polynomial phi x which will be approximately equal to f of x, or that satisfies this phi of x, satisfies this tabular values. Then that type of interpolation or finding a polynomial is interpolation, or which is known as polynomial interpolation. And in this chapter we are studying such a polynomial interpolation. So interpolation is estimation of a value which is not given in the table from the given discrete data. From these tabular values we have to estimate an value, intermediate value of the x, y for given value of x, and obtaining a polynomial for these data. And now we will see what is the meaning of finite differences. Suppose we have a table of values, that is here we have written x0, x1, x2, etc. and the corresponding value of y are denoted by y0, y1, etc. and here the values are equally spaced. That means the difference between any two successive values of x is the same. So what is a first value is x0, what is second value, it is x1, but x1 is x0 plus h, x2 is x0 plus 2h, and x3 will be similarly x0 plus 3h. So the difference between these two values, any successive value, is h. x1 minus x0 is h. Similarly x2 minus x1 is h, and so on. And last value will be xn is equal to x0 plus n times h. So then these values are said to be equally spaced. Now we will consider what is the meaning of forward differences. And if y0, y1, yn denote the set of values y0, y1, y2, etc. and if this is xn, the corresponding value will be yn. And these are the values of y. Then the differences of the values of y we will consider. That is y1 minus y0 or y2 minus y1, the difference between two successive values of y, and yn minus previous one, that is yn minus 1. These are differences of y. These are the differences of y. We denote these differences. First difference y1 minus y0 by delta y0. Second difference y2 minus y1 by delta of y1, and so on. So this is forward difference because delta of y1 is y2 next value minus existing value. and so on, that is delta yn minus 1 will be yn minus 1. So that is written again separately. Delta of y0 is y1 minus y0, delta of y1 is y2, next value y2 minus y1, and delta of yn minus 1 is yn minus 1. So these differences here, delta is called the forward difference operator. This is a Greek letter, capital delta. Small delta also we are going to use, but this is capital delta and this is small delta. So this capital delta is used or called forward difference operator. This is the operator, difference operator, it gives the difference. And delta y0, delta y1, delta yn minus 1, which are here written, are called the first forward differences. These are the first forward differences. And the differences of these differences will be the second forward differences. The differences of the first forward differences are called second forward differences, and these are denoted by delta square y0, delta square y1, and so on. So that will be the second forward differences. Now we will calculate what is the second forward difference here. So we have first forward differences we have written here. These are the first forward differences. Now we have what is the delta square y0, that is second forward differences. For the first forward differences it is only delta. Second forward differences it will be delta square. Third forward differences it will be delta cube, and so on. So what will be delta square of y0? This is again double operator of delta. Delta of delta y0. And what is delta y0? This is delta of, see, delta y0 we have it y1 minus y0, and therefore this will be delta y1 minus delta y0 operating on this. And what is delta y1? That is y2 minus y1. See, by definition delta of y1 is y2 minus y1. And what is delta of y0? That is y1 minus y0, delta y0. And thus the second order difference at forward difference at y0 will be y2 minus 2y1, the difference y1 minus y1, and the last will be positive plus y0. So this is delta square y0. And what will be delta cube y0? Delta cube y0 will be delta square cube y1 minus delta cube y0, operating on this delta cube y0. Next value, that is y1, delta cube on y1 minus delta cube of y0. See here delta y0. So this will be delta square y1 minus delta cube y0. So delta cube of y0. First we have to separate delta of delta square y0, and delta square y0 is this value we have obtained. So therefore this will be, or actually this is delta of delta square y0, and that is delta of, what is the delta square y0? You see delta square y0 minus, here it is delta square y0 is, and that is delta, or which can be written as delta square y1 minus delta square y0, and that value delta square y1 can be written from this. Delta square y0 is y2 minus 2y1 plus y0. So we want to write delta square y1, and that value can be written as in place of 0 we have to put 1. That means we have to increase the value suffix by 1, and thus this is y3 minus, so that I will write here. So this is delta cube y0 is equal to delta square y1 from this, or we may suppose this as 1. and increase the value by 1 of each, and that gives y3 minus 2y2 plus y1 minus delta square y0, it is the same, that is y2 minus 2y1 plus y0, and thus this is y1, and this can be simplified as y3 minus now you see 2y2 minus y2, that is 3y2, 3 times y2, and negative, and then y1, you see y1 it is positive, y1 plus 2y1, that is 3y1, and last is minus y0. So this is the value of y delta cube y0, etc. The higher order differences can be obtained. This is second order, and this is third order, this is second order, this is third order, and fourth order, fifth order differences can be obtained. So we after this we will construct a table for forward differences, forward difference operator, and for that table I will draw here forward difference table. We will consider the value of x here, the value of y, and see the values can be written, and then the differences, delta, first difference. So value of x, starting value we consider as x0, then x1, x2, x3, etc., x4, x5. And the corresponding value will be y0, y1, etc. Now first difference is we have written here as a delta y0. Delta y0 is y1 minus y0. So therefore this is y1 minus y0. The difference is delta delta y0. So this is delta y0. Difference between these two. Similarly, delta y2 minus y1 is delta y1. Difference of these two is delta y1, and difference of y3 minus y2 is delta y2. We write in between this, keep space between these values and write the value of difference in between these two values, because this is the difference of y1 minus y0, this is the difference of y2 minus y1, and this is delta y3 is delta y2 is y3 minus y2, and this will be delta y3, and this is delta y4. So these are the first differences. Now the second differences can be written likewise, delta square. So that will be the delta square at y0 is delta y1 minus delta y0. So this is delta square y0. Difference of these two is second order difference of, these are the second order differences, delta square y0, and this will be delta square y1. This difference delta y3 minus delta y2 will be delta square y2, and this will be delta square y3. So these are the second order differences. Then we will consider delta cube. Delta cube will be the difference between these two. This will be delta cube at y0 first. So delta is forward difference, means the next value is subtracted from the previous value, y1 minus y0, and this is delta cube at y1, and this will be delta cube at y3. So y2, delta cube at y2, that is delta square y3 minus delta square y2. So these are the values, and next difference will be written as delta fourth forward difference, delta raised to 4, and that will be here delta raised to 4 at y0, difference between these two. And similarly this is delta 4 of y1, and finally we can write fifth order difference as the difference between these two, and that is delta to the power 5 of y0. So thus in this way we have to construct the forward difference table using the definition of this delta operator. Delta of y0 is this, or in general delta of yn minus 1. Delta of yn minus 1 is equal to yn minus 1. So this is the definition for delta, so that we have to remember. Forward difference. Now we will consider exactly similar way, that is a backward difference operator. And backward difference, we will consider its operator and definition. Or that is backward differences. If we have the differences, if the differences, the same differences we have to consider, these are the differences in the values of y, and we consider again the same difference. Same difference means y1 minus y0. See, y1 minus y0. If the difference is y1 minus y0, then y2 minus y1, and so on, then that will be yn minus 1 are denoted, are the backward differences. Del y1, this is the symbol for backward difference. The symbol for forward difference is capital delta, and for backward difference we use this symbol, inverted triangle, that is del. And if we denote this symbol y1 minus y0 by del y1, then this as del y2, backward difference at y2, and so on, and the last will be del yn. Then that is if we have y1 minus y0, and that is del y1. Del y1 is y1 minus y0. Del y2 is equal to y2 minus y1, and so on. Del yn is equal to yn minus 1. Then the operator del is called the backward difference. Why this is called backward difference? Because the difference is taken in existing value minus the earlier, the back value, that is y0. So this is y1 minus y0, and for delta y0 it is taken first forward value y1 minus y0. So only the symbol is different. So delta y1 minus y0 is we have, say, y1 minus y0 is delta of forward difference at y0. This is delta y0, but the same value is backward difference at y1. So this is to be remembered. Value will difference is the same, but it is forward difference at y0 and backward difference at y1. That is to be noted. So this is the operator. The operator del is called backward difference operator. and the differences, or we can say delta, see here these values, delta, del, not delta but del y1, del y2, etc., del yn are the first backward differences. And similarly, the higher backward differences can be obtained as in earlier case, that is del square, del cube, etc. Similarly, the higher backward differences can be obtained. Now, for example, we can have see del square of y2, del square of y2 is equal to, it will be del y2 minus del y1. So this is, or we can say this as del of del y1, del of del y2. And what is the del y2? Del y2 we have here, that is, this is del of y2 minus y1, or that will be del y2, again del y2 minus del y1, and both values are here. How to express the higher order backward differences? Del y2 is y2 minus y1 and del y1 is y1 minus y0, or which gives y2 minus 2y1 plus y0, and so on, etc. So del cube of y3, etc. can be obtained. So these are the higher order backward differences, and thus the backward difference is defined by this, or you remember 1, that is sufficient. So now we will consider the backward difference table and see the difference in what is the forward difference table and backward difference table. The values we will take of x and y as the same values, equally spaced, that is x is, and this will be x and this is y. So x values will be x0, x1, x2, etc. up to x5 we can write, and then the corresponding value will be y0, y1, y2. These are the values given. Now what we will have to consider is del, first operator del at this. So what is the del? Del of y1, del y1 is y1 minus y0. What is the definition we have written is del y1. See, the definition is del y1 is y1 minus y0, and therefore y1 minus y0, this difference will be del y1. So this will be del y1. This difference. Now you see the same values are there and this same difference is there, y1 minus y0. We have written here that as delta y0, which is same as del y1. So differences of these two we have to consider. So this difference is here, and thus this is del y1. This will be del of this y2 minus y1, that is del y2, and this is del y3, and likewise this is del y4 and this is del y5. Del y5 is y5 minus y4, difference of these two values, successive values. So this is del. Now del square. Del square will be difference of these two, del y2 minus del y1. So that will be del square at y1. This will be del square that is del y2 minus del y1. So here we have del square y0, but it will be del square y1. And what is the difference of these two? So this is del square, and that is again, see, that will be del square y2, difference of this, that is del y3 minus del y2, that is del square y2. This is del y2 minus del y1, that is del square y1. Similarly, this will be del square y4, y3, del square y3, that is existing minus del square y3 will be existing value minus the previous value. So is it right? We will check what is del y1, del square y1. So this should be del square y2, it should be del square y2, this should be del square y3. So this should be del square y2. So del square y2 will be del y2 minus del y1. So del square y2 is del y2. And what is del y2? Del y2 is y2 minus y1. So this is del y2 minus del y1. Del y2 minus del y1 is del square y2. So we should correct it. Del y2 minus del y1 is del square y2, and this is del y3 minus del y1 is del square y3, and this is del square y4, this value, and this will be del square y5. So these are the second order differences. Now what will be third order? Del cube. Del cube will be the differences of these two, and this is del cube y3. Here we have to write the next value, and here we have to write the earlier value. Here we have written y0, and there we have to write the this value y3 minus y2. The difference is backward, and this is del cube of y4, and this is del cube of y5. This is del cube. And what about del 4? Del to the power 4. So this will be del 4 of y4. And next, del 4 of y4, and this will be del to the power 4 of y5. And finally, the operator will be del to the power 5, and that is del to the power 5 of y5. So this is the table that we have, and which is the backward difference table. You see, this is backward difference table and this is forward difference table. Actually the value will be the same. So this is difference of the y1 minus y2, and that is delta y0. Here we have written del y0. This is difference of y2 minus y1. We have written del y1. Here we have written delta y1, and which is same as del y2. Delta y1 is same as del y2. So or the relation actually will be delta y0 is same as del y1. So this value is same as this value, and thus the table remains the same. Actually the value remains the same. Further, in cubic form, you see delta cube y2, this value is a third value in the difference, third difference, and is this value. So this value is same. Delta cube y5 and delta cube of y2, this value, position is the same. So the same number occur at the same position, but only there is no change in the notation. Here it is a delta and here it is a del, and also not only that, but it is the operator, the point of y. The y value is also difference. This is delta of y0 and this is del of y1, further value. So thus this is to be noted between forward difference table and backward difference table. Now we will consider what is the central difference. Central differences. Central differences are defined by small delta, and we have these are defined central differences, the central difference operator. Operator is delta and is defined as, and we define y1 minus y0 is equal to delta y at half. Center of this 1 and 0 is half. So that's why it is central difference. Or we see the mean of 0 and 1, that is half. And similarly y2 minus y1, that is delta y 3 by 2. Difference of y2 minus y1, and this is 2 plus 1, that is 3 by 2, and so on. And yn minus 1. So what will be this? See, this will be delta y and the sum of these two divided by 2, that is 2n minus 1 divided by 2. So these are the central differences, and likewise higher central differences can be defined. Now we shall form a table for central differences, central difference table. The value of x and y will remain the same. Instead of this del, we have to write small delta. So this is small delta. And now you see this y1 minus y0 is small delta y half. So this difference is small delta y half. And likewise this difference, the difference of these two will be delta y2 minus y1, see 3 by 2, and this will be delta y 5 by 2. Sum of these two divided by 2, that is central difference, average is considered here. And delta, this will be y 7 by 2, and this is delta y 9 by 2. This is the first order differences. Delta square, second order. Delta square will be the difference of these two, and that is delta square. Delta square, see the sum of these two, which is 2. 4 plus 1 is 3 plus 1 is 4 by 2, that is 2, and 2 divided by 2, that is 1. So delta square y1. See, what we are going to considering here is half plus 3 by 2 divided by 2. Every time we are 1 plus 2 divided by 2, that is 3 by 2. Likewise half plus 3 by 2 divided by 2, that is, here this is 2 divided by 2 is 1, so it is y1. And similarly this difference, second order difference, difference of delta is second order difference. And what is the sum of these two? It is 4, and 4 divided by 2 is 2, delta y2. And this is, you can check, delta square, the sum of this is 12 by 2, that is 6 divided by 2 is 3, and this is delta square, and the sum of this 7 plus 9 is 16 by 2 is 8, 8 divided by 2 is 4. It should be written y3. This is y4. Thus, these are the second order differences. Now, what about third order differences? Delta cube. So, this will be delta square y1 minus delta square y2 minus delta square y1. So, sum of these two, 1 plus 2, that is 3 by 2. So, delta cube y 3 by 2. And this is delta cube y, this is 5 by 2. Check it. And delta cube y, this is 7 by 2. These are the third order differences. Fourth order differences will be delta fourth of, this is again 3 plus 5 is 8 by 2 is 4 by 2 is 2. Delta to the power 4, and this will come to be 3, y3, check it. And delta 5, this will be delta 5, and y2 plus 3 is 5, so divided by 2, y 5 by 2. So, in this way the central differences table can be written. And now you note that in all the difference tables, in the difference table, forward, backward and central, and central difference tables, the same value appear at the same position, and we have the relation for this. Say we have is y1 minus y0. See, y1 minus y0, what is this? We have denoted as delta y0. This is del y1 and this is delta of y half for the first differences. And likewise we have delta cube of y 5 by 2, see 7 by 2, this is also, you can check this. Which value we have written is delta cube of y2 is equal to see, it is delta square, delta cube of y2 we have written earlier, delta cube of y2, which is same as delta raised to 5 of y2, not delta but del. You can check the corresponding position, the value. So this is third value, and that is third value in this column, or any value in any column. You can check this value will have the corresponding value in backward difference table and forward difference table. So that is delta cube y2, which is del fifth of y2, and this is equal to delta cube of 7 by 2. You should check this value. So whether it is the same, you please check, verify this whether it is the same or not. So this value, third value, we have written earlier also, and thus you can consider this, and you should please check this. So thus we have studied here the forward difference table, backward difference table and central difference table. It is easy to obtain the table. So for example, if we have, see, the values of x and y are given. Suppose these are the values of x and these are the values of y, and x values are 1, 2, 3, etc. and corresponding values of y are say 4, 8, and it may be considered as any value, say 11, 14 and 16. So these are the values. So what will be the first difference? Delta will be y, this is y0, this is y1. That delta value will be 8 minus 4, which can be written here, 4, difference of these two. And 11 minus 3, 11 minus 8, that is 3, that is first differences, forward differences. 14 minus 11, that is 3, and 16 minus 14 is 2. So this is the first difference, delta. What will be delta square? That is difference of these two. The same thing we have done in each difference table. The values will be the same, only the notation is different. For forward we use delta, for backward we use del, and for central we use small delta. So this is delta square will be 3 minus 4, that is minus 1, and this value is 0, 3 minus 3, 0, 2 minus 3 again minus 1. And what is delta cube? Delta cube will be 0 minus 1, that is 0 minus minus 1, that is plus 1, and this is minus 1 minus 0, that is minus 1. What will be delta to the power 4? And this is minus 1 minus 1, that is minus 2. So actually this value is 4 value is delta of y0, and this value is same as del of y1, and this value is same as delta of y half. So thus the same table will be obtained for each differences, forward, backward or center, but the notation will be the different. So thus we have studied forward difference operator, backward difference operator and central difference operator and the corresponding difference tables in this lecture. So remaining part we will continue in our next lecture. Thank you.